Hello everyone, today we'll talk about the problem sum of square numbers. In this problem we're given an integer and we want to decide if it's possible to express that integer as a sum of two perfect squares. So if there exist two integers a and b, that a squared plus b squared is equal to the value c that we're given. One way to look at this problem is just as a two-sum problem. So we are being asked if it's possible to select two values in an array that sum up to c. And that array that we're given is just the array of all perfect squares. And in that case, we can use our preferred method of solving this two-sum problem, which would typically be making sure that the array is sorted, in which case we have this sorted array by default, since we just created by adding consecutive squares of consecutive values, for as long as they do not exceed the value c. And then we can utilize the fact that this array is sorted to, in linear time, find the pair of indices that sum up to our value c, or to report that such a pair doesn't exist, which is just to start from the left and from the right with two pointers, and those two pointers will be moving towards each other. If they pass each other, then that pair doesn't exist, and we return false. Otherwise, either we have found this pair, so we return true, or the sum of current values is too small or too large. If it's too small, we have to increase the left value, so we increase our I. Otherwise, we have to decrease the right value. So if you're unfamiliar with solving this two-sum problem, then you can think about it. Look at the code and convince yourself that it works. Otherwise, this is just a simple application of the standard technique, although there are also some other solutions. One other solution that is essentially equivalent to this two-sum approach, but maybe more natural to somebody who doesn't think about this problem, is that we can still go through all the possible squares. Then, by subtracting the square that we're thinking about from the number c, we can binary search the other number. So we can look at the other number, square it, and look if it's too big, too small, or exactly right. And then this is essentially the same thing that we're doing here without creating this array explicitly. But then we have the logarithmic factor for binary search.